everyone, my name is CHE244 and welcome to our project video for CHE244. Today our team will discuss about water waste treatment activity slab process. Water waste treatment is an essential environmental protection process that removes contaminants from domestic, municipal and industrial water waste from its discharge into natural water bodies. Industrial and municipal activities produce billions of liters of highly polluted water waste every day. This untreated water contains massive amount of dissolved organic contaminant, measured as biochemical oxygen demand, or we can call it BOD. If this water is released into the environment raw, it depletes natural oxygen, suffocate aquatic life and spread pathogen. One of the most widely used biological water waste treatment method is the activate sludge process. The activate sludge process was first developed in the early 20th century and it remains one of the most effective technologies for removing biodegradable organic pollution from water waste. The process utilizes a mixed population of microorganisms commonly used known as activate sludge to biologically oxidize oxygen contaminant in the presence of dissolved oxygen. The activated sludge process is extensively used in municipal sewage treatment plants as well as various industrial sectors such as food processing, dairy manufacturing, and palm oil processing industry. Its popularity is attributed to its high treatment efficiency, flexibility, and ability to produce high-quality treated effluents suitable to discharge for future treatment. As you can know, this process follows this process flow diagram. Look at the process flow diagram for the process. First up, we have the primary clarifier. Raw wastewater into this initial settling tank first. Here, we basically let gravity do its thing. So, heavy debris and large solid can sink to the bottom. This step is super important because it takes a huge lot of the biological units downstream. Second, the fluid moves into the aeration tank. This is our biological reactor. In this tank, we pump in a massive non-stop supply of oxygen from the bottom. This creates the perfect environment for our resident bacteria to wake up, get active, and start eating the dissolved organic pollution. Third is secondary clarifier. After the aeration tank, this mixture, which we call mixed liquid, flow into a secondary setting tank. Here, the water becomes completely still, allowing the bacteria to naturally stick together into heavy clump called floc. Sink to the bottom. This level crystal clear treatment water of the top ready to be safely changed. Fourth, we have the RAS and WAS lock. The biological sludge that settle off the bottom is split into the two pipelines. Most of it pumped right back into the front of the reactor through the return activate sludge (RAS) line to keep our army of bacteria work stronger. Meanwhile, because the bacteria naturally multiply, any excess sludge is permanently purged out through the waste activated sludge line to keep the whole system perfectly balanced. Next, we move to chemical and biological reaction. The activated sludge process primarily relies on aerobic biological reaction to remove organic pollution. During treatment, microorganisms utilize organic compounds as a source of energy and nutrients. In the presence of dissolved oxygen, these pollutants are oxidized into simpler and less harmful products. The overall biological oxygen reaction can be represented as follows: organic matter plus oxygen and plus organism, 2 carbon dioxide plus water and new biomass. The reaction reduces the BOD of wastewater. A microorganism consumes organic pollutant. The concentration of contaminant It decreased significantly, improving the quality of the treated effluent. In addition to organic material removal, nitrification may occur within the aeration tank. Nitrification is a biological process in which ammonia is oxidized into nitrate through the action of specialized bacteria. This reaction helps reduce ammonia toxicity and contribute to improved water quality. Now, that's all from me. I will pass to my group members.
So, I will continue the presentation for my part. So, for my part is the reactor type selection. For the reactor, we use is aeration tank for activate slug process. So, aeration tank is similar to continuous direct tank reactor, which known as CHE244. In CHE244, reactor continuously enter the reactor while the product will leave, and complete mixing is assumed throughout the reactor volume. The aeration tank exhibits characteristics similar to CHE244 because wastewater will enter continuously and the mixed liquid will exit continuously, and a mechanical mixing ensures a relative uniform concentration of microorganisms and dissolved oxygen throughout the tank. The aeration tank is constructed as a large rectangular equipped with aeration device. Wastewater will enter the reactor through an inlet channel. Air supply is for diffuser located at the bottom of the tank. The primary function of the aeration system is to maintain mixing within the reactor. Bubble aeration is like a stirrer in CHE244 that help proper mixing, ensure uniform distribution of microorganisms throughout the tank. The major components of the aeration tank include wastewater inlet, air diffuser, mixed liquid zone, outlet channel, and the return activate slug line. Several operating parameters influence the performance of the activate slug process. Temperature will affect microbial growth and reaction rate, with optimal performance generally occur between 55 degrees Celsius until 35 degrees Celsius. And for the pH, the wastewater is typically maintained between 6.5 until 8.5 to support microbial activity. For dissolved oxygen concentration is the one of the most critical parameter in the process. Dissolved oxygen level between 2 and 4 mg per liter is generally maintained to ensure sufficient oxygen for aerobic microorganisms. For hydraulic retention time (HRT), typically range from 4 until 8 hours. Mixed liquid suspend solid (MLSS) concentration are commonly maintained between 2,000 and 4,000 mg per liter to provide an adequate microbial population for pollutant degradation. The activate slug process use microorganisms as a biological catalyst. This microorganism accelerate the degradation of organic pollution without being permanently consume the overall treatment process. So, the microorganism that we use is Bacillus, Nitromonas, and Nitrobacter. This microorganism require favorable environment conditions to remain active and effective. The performance of the activate slug process is commonly evaluated based on pollutant removal efficiency, residence time, mixing effectiveness, and the other. Residence time refers to the average duration wastewater that remain in the reactor. Adequate residence time allows microorganisms sufficient opportunity to degrade organic contaminants. Mixing efficiently is equally important because it promotes contact between pollutant and microorganism and also the oxygen. Effective mixing ensures uniform treatment condition throughout the reactor and minimize the formation of stagnant zone, and it can reduce the treatment efficiency. So, under the proper control condition, the activate slug process can assist biological oxygen demand removal efficiency exceeds 90%, and it can also significantly reduce suspend and solid ammonia concentration. So, I think that's all for my part. I'll pass this presentation to Izafifah to continue it.
Thank you, Aiman. Now I'm going to explain my part with its advantages, limitation, and safety consideration. The activated sludge process offers several advantages including high treatment efficiency, operational flexibility, reliable performance, and the ability to handle large wastewater volumes. The process is well established and has been successfully implemented worldwide for municipal and industrial wastewater treatment applications. Despite its advantages, the process also has limitations. The aeration system requires substantial energy consumption, making operational costs relatively high. Additionally, excess sludge generated during treatment must be managed appropriately, which increases overall treatment complexity. The process is also sensitive to toxic shock loads and sudden changes in wastewater composition. Safety is an important consideration in wastewater treatment facilities. Workers may be exposed to biological hazards, toxic gases such as hydrogen sulfide, and electrical equipment associated with pumps and aeration systems. Appropriate personal protective equipment, gas monitoring systems, regular maintenance, and operator training are necessary to ensure safe operation of the treatment plant. The activated sludge process is one of the most effective and widely applied biological wastewater treatment technologies in modern environmental engineering. The process utilizes microorganisms to biologically degrade organic pollutants under aerobic conditions, thereby improving wastewater quality and protecting the environment. The aeration tank serves as the primary reactor and can be modeled as a continuous stirred tank reactor due to its continuous operation and efficient mixing characteristics. Proper control of operating parameters such as dissolved oxygen concentration, temperature, pH, and intention time is essential for achieving optimal treatment performance. Overall, the activated sludge process provides an efficient, reliable, and sustainable solution for wastewater treatment. Its widespread adoption in municipal and industrial facilities demonstrate its importance in environmental protection and water resource management. That's all from our group. Thank you.